Miss Lindsay here with your last video of the year, two-way frequency tables. Two-way frequency tables, comparing sets of categorical data. What is categorical data, you may ask? It's data that is non-numerical. We've mostly been dealing with numerical data in this course. Obviously, it's a math course. But you've learned plenty over the years about non-numerical data. Back in elementary school, I'm sure your teacher talked about categorical data, but didn't call it categorical data. You might have been asked, what is your favorite color? And your teacher might have taken the information from your entire class about your favorite colors and made a bar graph where you could find the mode, the most popular color in your class. Your teacher later on might have made pie charts so you can see favorite colors displayed in other ways. You might have been asked what month your birthday was. Months are not numerical. That's categorical data. In last year and this year's classes, we talked about one set of numerical data. We were able to get one list of data, and this year we learned how to type it into our calculator, into the stat edit stat calc number 1 for one variable statistics, one list of data. One list of data, you could make a dot plot. If you got the median, the first quartile, the third quartile, the max, the min, you could make a box plot. You could split it into intervals and make a frequency histogram. You could even find the modal or the most popular bar in your frequency histogram interval. We also could get the mean, which was X bar. We also talked about two sets of numerical data. And from two sets of numerical data, we made scatter plots in which you graphed on an XY graph and drew a line of best fit, the line that was as close as possible to each of those dots. You were able to do that also on your calculator with stat calc number 4, the linear regression. Today, we're going to talk about sets of categorical, non-numerical data. And for that, we're going to use two-way frequency tables. So, to read a two-way frequency table, if we'd like to compare two types of people, left-handed and right-handed people, and decide if being male or female may have some sort of an implication on being left-handed or right-handed, we might make columns and rows, a two-way frequency table. So we need to finish the table by finding what's called the marginal frequencies, the totals. So the males, there are 4 left-handed, 23 right-handed. When we add those together, we have 27 total males. 5 and 20, we have 25 total females. When we add the columns together, we get the margins on the columns. 4 left-handed males, 5 left-handed females is 9 total left-handed people. And 23 and 20, we have 43 total right-handed human beings. We add all that together along both margins. The rows and the columns should both add to the same thing. In this case, it's 52. From here, it's pretty easy to just answer the questions that you're asked. How many females are surveyed? We go to the total females, only looking at the female row, and we have a total of 25 females. How many left-handed males are surveyed? Well, that's a little more specific. We have to go to the left-handed column and the male row. There are 4 males who are left-handed. How many right-handed people? Well, it doesn't seem to matter if they're male or female. how many right-handed people, we go to the column of right-handed people, 43, whether male or female, are right-handed. And the grand total of how many people are surveyed, we can see on our chart, is 52. So finishing a frequency table, a two-way frequency table, is pretty easy. It's like filling in a puzzle. So if we want to find the total number of men, whether they like science, humanities, or art, we can just subtract the 162 minus the 74. And I like to start on my margins, but you don't have to. And we get a total of 88 men. We already have the 74 female. If we subtract 162 minus the total that we have here of science and humanities, which is 106, so 162 minus 106, we get 56. And now we can just fill in the missing pieces. 46 minus 24, 22. I would say 56 minus 25 is 31. If I add together my 24 and 25, I have 49. And subtract that from my total women, 74. If I subtract that, I get 25 women who like humanities. And simply 60 minus 25, we get 35 men who like humanities. Now, when you get the percent of people, remember from last year that percent is part over whole times 100. Or move the decimal 2 places, however you like to think of it. I like to multiply by 100. So the percent of people, this is your whole, this is your total. So if you look at the number of people, well, we can see the number of people here is 162. That's what it's out of. So 162 would be your denominator. And then we just find the part, those who like science. There are 46 who like science, so 46 would be my numerator. If I multiply that by 100% and round it to the nearest tenth, I get 28.4%. You'll be asked this question in a multiple choice, so you'll simply pick the closest answer to 28.4%. What percent of men who like art? What percent of people are men who like art? So again, of people, we're dividing by the total number of people, 162. How many of those are men who like art? Well, men who like art, that's pretty specific. That's in here in what's called the joint frequency. So that's 31 over 162 times 100. And we end up with 19.1%. Now, sometimes we want to find what's called conditional relative frequency, based on the condition. It may not be based on the total. So again, what I would like to do is fill in the rest of the missing pieces in the table. And for that, when I read the instructions here, it says Marty surveyed 76 adults. Well, I know that 76 is my grand total. I'm going to fill that in first. And the rest I can pretty much get by subtracting. 76 minus 24 is 52 total people who have kids. And then people who have kids and no pets, I would just subtract 52 minus 37. I'd get 15. And if I add 15 and 15, I have 30 total people who do not have pets. And then if I subtract now 76 minus 30, I have 46 total people who have pets. And 24 minus 15, I'd have 9 people who have no kids and who have pets. And again, if you want the percent of people who have kids now your denominator is a little bit different. It's conditional. It's not out of the total 76. It's just out of the 52 people. The 52 people here who have kids. That's my denominator. The numerator are those in this particular column who have pets, 37. Take your calculator, divide those, multiply by 100%, and you should end up with 71.2% people who have kids out of what percent of people who have kids have pets. What percent of people who do not have pets? Okay, once again, of people who do not have pets. Let's focus in on the row of people who do not have pets. So I'm just looking at the no pets row. And there are 30 total people in the no pets row. So I'm going to divide this by 30. And I'm going to use my numerator, people that do not have kids. Let's focus in on that row only. People that do not have kids, there's 15. So 15 will be my numerator. Make that a better 15 for you. 15 divided by 30, multiply that by 100. No rounding necessary. You'll get an even 50%. Okay, the next one is for you to try on your own. Mr. Balsamo wanted to see if there was an association between dogs who are Dalmatians and deafness. There's been a rumor that Dalmatians have more chance of deafness than regular dogs. So he made a table here. You're going to have to fill in the totals. And then the grand total. And then find the percent of dogs, that would be out of the total, who are not deaf. And then you're going to have to find the percent of Dalmatians. Well, remember, Dalmatians would simply be this row here. Okay? So give that a try on your own.